Hi, I am Jan Dill of Enterergotics. I'll give you this demo as an introduction to our analytical software service. Consider our service as a training to fly a flight simulator on Wall Street. This simulator confronts you with the sometimes violent turbulence out there. This turbulence includes massive sell-offs, blood in the street, elections with unsure outcomes, Brexits, and times of collective investors' exuberance. Such rough rides are simulated by using true historical exchange data, up to 55 years deep. In this part of the demo, I shortly introduce you to terms often used in investment land. These terms are like game plans, optimal portfolios, investment objectives, expected risks and rewards, rebalancing, screening, ranking, timing and weighting, and estimation. The time-sensitive behavior of stock values may be analyzed with technical analysis. Technical analysis uses historical exchange data. This time-sensitive behavior may also be analyzed with fundamental analysis. Fundamental analysis uses company and economic data of historical and forward-looking nature. The objective of such analysis is to try to indicate future behavior of single stocks. Indicating future behavior enables one to rank stocks by decreasing likelihood to be successful. Such indications may even influence future behavior. Financial markets are unpredictable, but vulnerable to manipulations. Fund Manager doesn't use technical or fundamental analysis. It screens for stock to trade in perfect competition, based on historical exchange data. It ranks stocks by assuming the statistical behavior of ergodicity for the value fluctuations of the stocks over time. Ergodicity implies that at any time, a time average of the fluctuating historical data of each stock equals an ensemble or weighted portfolio average of stock data. This behavior enables us to separate the bulls from the bears in the ranking process. Mathematically, this process of separating the bulls from the bears involves considerable data mining and number crunching. It involves filtering, which is called stock screening in investment land, sorting, which is called stock ranking, and estimation, which is called stock timing and weighting. It proves to be highly effective and efficient. This assumption enables our analytical services to take an innovative approach to analyzing stock ensembles of portfolios rather than single stocks. It enables us to analyze the timeless behavior of stock ranks in optimal portfolios. It validates the accumulating risks and rewards of these optimal portfolios resulting from self-configured investment plans. We call such plans game plans. A game plan is timeless. Therefore, its validation is the backtest of sequential investment decision on rebalancing the optimal portfolios at specified times. The first question that comes to mind is how do we obtain optimal portfolios in relation to investment objectives at specified times? Secondly, what can we use as investment objectives? And thirdly, how do we assign a number to expected risks and rewards? What do these numbers imply? I address that in the next 3 slides. A stock portfolio is simply a grouping of stocks. It is often called a basket of stocks. Optimal groupings are optimized to maximally serve your investment objectives. Suppose your objective is to minimize risks. Fund Manager searches for stock weights in each portfolio that truly minimize your risks. It performs such a search by automatically varying the weight of each rank in the portfolios. We developed our own search algorithm to perform this optimization process almost instantly. Such a process is called an estimation process. The next question is, what can we use as an investment objective besides minimizing risks? That shows the next slide. Fund Manager lets you set your investment objectives as to minimize risks, maximize rewards, or minimize the risk-reward ratio. This ratio can be considered as an alternative to the inverse of the so-called Sharpe ratio, a concept that is known in financial circles. After having set your investment objective, the next question is how do we give numbers to expected risks and rewards? These numbers should have a practical meaning. And what does the word expected imply? Let us consider the following slide. Risk and rewards are usually quantified based on historical behavior. Think back in time. Each week we can determine the optimal stock portfolios using DigiFund Manager. Each week we may choose to invest the same constant investment amount in these optimal portfolios. This process is called rebalancing or shaking up a stock portfolio. With this rebalancing process, free cash may be added to or needed by your account. This free cash accumulates over time. Accumulated free cash, averaged per year, is considered as the expected reward of your game plan. In statistics, averaging a quantity over time is usually called the expected value of that quantity in the future. Expected values have no relation with a deterministic future prediction. Accumulated free cash plus the portfolio value is called the net liquidating value of your broker account. Net liquidating value is often abbreviated by NLV. A maximum drawdown in the NLV from a temporary top to a temporary bottom relative to the investment amount is considered as the expected risk of your game plan. So the only thing we are left with is how do we actually calculate the expected risk and reward from a sequence of optimal portfolios? To answer that question, let us first give a visual illustration. Let us schematically chart an imagined NLV. This shows the following sheet. Consider the chart of the sheet. The onset of the historical data in our database lies on December 29, 1961. The red curve in the chart shows an imagined fluctuating net liquidating value of optimal portfolios yearly rebalanced. The risk or maximum drawdown is shown to happen over 1963. It is the maximum of the two drawdowns. The constant investment amount is indicated in light green. The accumulating free cash can be calculated by subtracting the constant investment amount from the NLV. The expected reward is the accumulated free cash divided by the constant investment amount, averaged per year. It doesn't really matter for DigiFund Manager whether it deals with a rebalancing rate of once per year or once per week. It's up to the user to set this rate. In the chart, it is assumed to be once a year. The impact of the rebalancing rate on risk and reward may be very high. Now let us come back to the question, how does DigiFund Manager determine optimum portfolios? Let us move to the next slide. The program first needs a list of all active stocks on Wall Street. A list of all currently active stocks is regularly updated and downloaded from NASDAQ.com. We only put stocks on this general stock list when the companies report their financial results to the Securities and Exchange Commission. This commission is usually abbreviated by the SEC. The NASDAQ list contains some 6,800 active stocks reporting to the SEC, including some 325 investment funds. DigiFund Manager determines optimal portfolios of any size from this list at any specified time. It uses the so-called time series of historical exchange data of each stock in the list for its screening, ranking, weighting, and timing processes. The historical data go back to 55 years deep. Running a game plan should preferably result in a continuous generation of free cash with minimum drawdown and a maximum slope. This continuous fight between bulls and bears is expressed by our logo. Our company name is Enterergotics. Enter is the village where we are located in the Netherlands. Ergodicity is statistical behavior that we ascribe to the financial markets. The validation over the past of a self-configured game plan should reveal whether its expected future performance achieves the investment objectives of the user with reasonable confidence. That brings us to the last sheet. What is new in DigiFund Manager? Expected risk and rewards of self-configured game plans are the result of assuming ergodicity for statistical processes on Wall Street. Automated sequential investment decisions, validated over 20 to 55 years. Automated selection of long positions with matched short positions. Automated optimal portfolio allocations and timing by optimizing risk-reward ratios. The risk-reward ratio as an alternative to the inverse of the Sharpe ratio. This is all benchmarked with a cap-weighted S&P 500, a price-weighted Dow Jones Industrial Average, equally weighted Monkey Index, equally and price-weighted self-configured game plans, so that beta, which stands for relative risk, and alpha, which stands for relative reward, can be gauged for 5 benchmarks with different asset allocations. This finishes the first part of our demo. Thank you for your attention.